Steve's just going to complete his setup, and he's using the CamJam Edukits with a different language. Hopefully some of you have heard about the CamJam Edukits that Mike and I produce. We've produced them for use in workshops, mainly in our workshops and in schools and for children at home. We've written it in Python. We will be at some point going to GPIO 0. There are other ways of using this hardware. It is, after all, just generic hardware. So it's great to see our Edukits being used with different things. So I'll hand over to Steve Lloyd.
Thank you very much. Right. So CamJam Edukits, as Tim mentioned, there are 3 of those, and they really are a brilliant way of starting to use physical computing on the Pi. One is a starter kit which has got sort of flashy lights and a breadboard. Kit 2 has got sensors, and Kit 3 is robotic. So today I'm just going to talk about using with this language called Racket, which I sort of say is fun and easy to use and quite powerful. If you want to get started with Racket and you do a comparison with Python, Hello World looks pretty much identical. It is identical. Where you want to add 1 and 2, it starts to look a little bit different, and therein lies quite a lot. So I'm going to do a couple of examples. There's a starter worksheet, or worksheet 3 for the starter kit, which is just blinking LED, and then a sensors worksheet, which is using a temperature sensor. And yeah, we can see that better under the device in a minute, but basically what I've got is a Pi with a little breadboard on top, just to make it easier to connect in some sensors, but it just comes out to a breadboard with the LED. So let's swap to. What I'm going to do is I'll stop this and start it again, because I realise. Right. So Racket, you can just install it like you do any other software on the Pi. There's a command called apt-get, which lets you install new software. And if you just say sudo apt-get Racket, you'll get Racket. And in your menu there, you'll see under programming, you've got a program called Dr. Racket. Okay. So installation is quite simple. Now what I'm going to do is just start the terminal. And I'm going to start at Racket from the command line because I want to use the I/O, and in this particular version we'll need to be the sudo user to be able to drive the I/O port. So I just started it in a slightly different way. Sudo Racket. Yeah. Pause. You see the opening screen. It's quite a big bit of software, so it runs nicely on the Pi 3. It runs okay on the Pi 2. On anything older, or say the Pi 0, it's brilliant for projects you've finished and want to just use the software to do something, but actually doing development is a bit tedious on anything lower than Pi 2. So when we start up, we get this screen here. It has two panes to it. On the left is an editor, So that if the equivalent of idle really, you've got on the left-hand side you've got an editor. On the right-hand side you've got a pane you can interact with the system with programs you've written already. So the first thing you'll notice that there's a first line in the editor, which is the standard line that appears. It's called lang Racket. It says we're going to use the Racket language because actually Racket comes with about a dozen programming languages you can use inside the IDE. But this says we're going to use Racket. And to be able to actually use something we've written in the left-hand pane, we have to hit the run button, which is on the right-hand side here. So we haven't written anything at the moment, but if we get that little arrow prompt, it means everything's fine. So if we start a program, we can say, okay. Oops, 20, that's not right. So you notice the editor put a hint at the bottom. It's read something, but it's expecting a closing bracket, and I put a 0. So let's do that. So we've edited that. If we want to run it, I'll just use the command key because it's quicker. It's pressing the run button. Phew, we get the right answer. And we can do things like this left-hand side. We can now start to define things. So to do that, we can say define. So let's go today, and we'll make today. So once we've done that, we hit run again, and we can start to use that now. So we can say today, meet Saturday. One thing you can do with Racket, which is slightly, this would please Alex if he was still in the room, so we can define, and now we can go to the menu here and we can say insert an image. So define Kitty, there's that image there. And again, if we run that, on this side we say, see, sure enough. And of course, like other, like Python or anything else, there's a huge amount of libraries for Racket which will do anything you like. And one of them is an image library. So if we start to use that, we've got to tell the system we're going to use that, so we just go require, and then the name of the library, which just happens to be H2DP image, for various reasons. Now if we run that, we've got that library available to us. So we can say something like, for example, let's say, rotate Kitty. Show that upside down Kitty. And there's various other. Once we've done that combined, we can start to just play with this in the right-hand side. So there is another feature in the lot of image features in the library. So there's something called beside. So if we say beside Kitty, okay, one Kitty beside the other. Fine. So far so good. So let's just now move on to the. We've covered everything there. Oh, I had another example. So this is we've got functions. Like we've got functions in Python, we've got functions in Racket. So if I run that now. Now then, something's gone wrong. It says unbound identifier. It means it has no idea what check expect is. Now, this was intended to sort of demonstrate how you build up programs for definitions. What you're meant to do is to say, I want to say hello to someone with a name. So what I do is, I say, for example, if I say hello Kim, I wanted to say hello Kim exclamation mark. And then down here, where I actually, I've got the definition of the function. Here I'm testing, so I'm saying, when you say hello Kim, I should get hello Kim exclamation mark. But it doesn't know anything about check expect. So this is part of the testing system. So if there's something that you want to find out about, you can just press F1, and with any luck, you get the documentation. Right. Okay, it just so happens, I'm cheating slightly, I know that is the one that I want. So, check expect, test whether something is right or not. And what we needed to do was to actually use, to bring in the library. Type that, select that out, select the whole page, go back to one there. Okay, so if we run that again now, that error message should go away. That's fine. And now to check that our test works for that, you can say test, oops, so that's well, that's so let's run that again. So we ran one check and it didn't pass. The code quality of this software is rubbish, and what it says is the actual value hello Kim differs from what it wanted was hello Kim exclamation mark. So actually what we're doing is we aren't actually putting the exclamation mark on the end. So if I say add exclamation mark, that runs again. The only test passed. Code quality of the system is now superb. So that's a function. So to define a function, we define the name of the function, and it takes a string in this case, which is the name. And you'll notice that as I'm highlighting this, it shows me in the program where the things are being used, which is quite handy. If you can, and then underneath there, I've done a sort of polite version of this, which takes into account the name of the country that you're in. So if we say we're in Japan, it's going to make that slightly more polite. So if we say polite now then, another mistake. But it gives me a hint as to what I've done. It expected two things, and I've given it one, so I haven't actually told it what country. Back. All right. Yeah, that worked. So there's defining functions. So there's a process for defining functions in Racket, which isn't all that different from the way it's in some other languages. Now go on to actual CamJam stuff. So here I've got a function. I'm going to run that again. What I've done is defined some constants. What we're going to do first of all is make a sort of a software version of what we're going to try and do in hardware. So one of the features of the image library is something called circle. So we can actually say draw a circle. So if I just type in there on an LED, we get a red LED. And equivalently, if we say off LED, we get a not LED. So that's my graphical interpretation of what that should look like. And so I've done a function here which says to draw an LED. And it takes a sort of true or false. Is the LED on? So that's a convention in Racket. If something is sort of a true or false value, you put a question mark. So it's like on. So if we say draw LED, and then it's expecting a true or false value, so we can use that for true. Yep, we get it. Now, there's also something, one of the libraries is called Universe, and there's a really good, if you like, animation library in Racket, which you use for drawing graphical programs. And what it does is, it imagines a world, and if you're simulating a world, you might have some state in that world. So if we're simulating the solar system, it might be the positions of all the planets. Here we're just simulating an LED, something slightly less ambitious, and the only bit of state we need is that LED on or off. So what will happen is this picture world LED, it uses a feature called Big Bang, which comes from the universe library. And what that does is it sets up a universe, and then it defines two things. So there's a clock in this universe that ticks every so often. And on each clock tick, we need to give it something to do to update the state of the universe. And in this case, we've got an LED, we want to flash it. So if it's on, we want to turn it off, and if it's off, we want to turn it on. So we actually say the new state from the old state is not what it is at the moment. So that turns on and off. Then the other thing goes to Big Bang is what to do to draw this new picture of the universe. So we say draw LED, so we've used that there. And then we've got another parameter here, which is how fast the universe updates, and that is in seconds. So in principle, if we try picture LED, and we do it 1 second, the tiny traffic limits there at the top, and sure enough, it's flashing. And we do stuff like change how fast the universe runs. We change that to 5. Okay, so that's an imaginary LED that we're playing. Now let's move on to the real LEDs. How much time?
You've got about 7 minutes left.
Okay, right. I shall speed that up a bit. Okay, flash. So here we've got a bit more code, and before I do anything else, I'll just make sure that works. Now, for driving hardware on the Raspberry Pi, there's a guy called Gordon Henderson who did a library called Wiring Pi, which lets you drive the hardware of the Pi from programming languages. And so I've got a Racket library which will allow us to drive hardware from Racket. And so we can do things like if you've ever used hardware on the Raspberry Pi, this refers to a particular pin number on the Raspberry Pi which we're going to connect the LED to, which is connected to already. And we're defining things like on is true and off is false. What we first of all got to do is, before we do anything else, is set up the I/O pins on the Raspberry Pi. So let's do that before we go any further. So that's set up I/O. So good. So now, in principle, what we can do is we've got a function there called LED on, which basically writes hi to that particular pin. So let's try that. Now, I won't switch on the projector because it'll all sort of make it all, but somebody can verify that LED is actually on. Yeah, Tim can't verify because you can't see it from here, but it's on. And equivalently, if we say LED off, it's gone off again. True. So I mean, this is very familiar if you've done any programming of Edukits with Python. It's sort of very similar in many ways. Again, the nice thing about this is with Racket, you can build things up as you can in Python. You can build things up a little bit at a time and then plug them together. So it's very much like Lego. So we've got flash once there, which somebody in the audience will have to look very, very quickly on that. Flash once coming. Yep, flash once. Yep. So what I'm now going to do is plug that into the same sort of code that we used for the imaginary LED. And I'm actually using the same code that we did, because we're going to have a graphical one and a real one going side by side. So we've got, we've changed draw LED. So what it does now is, it returns a picture of the LED, whether it's on or off, but it also sets the real world LED. So it's the same sort of thing. It's typing. Yeah. So yeah, we do have a flashing LED once a second and the equivalent imaginary one on the screen. So let's just get rid of that. And let's try the same test again. It's flashing. Second. And the thing I was just saying, the thing I like about this is that you do build it up like tiny little Lego blocks until it does what you want, basically. Okay, let's move on to the temperature sensor. So in the CamJam Edukit 2, you get a whole variety of sensors. One of them is this temperature sensor here. So, temperature. And again, you just need to run it just to get all the definitions in there. Now this is a little bit more involved. Let me just, what it does is it calls a library that I've written, which deals with the sort of sensor that's in the Edukit. So it's a thing called a one-wire device. And if we just open that, let's just open that. I just want to check on the name of something. It's in there. Okay. So this is just a library we can make use of now, which encodes various things about the sensor because it has a really strange way of displaying things, or the data from it needs to be decoded to make it work in the real world. So this function here it says read temp raw from a particular device. So the raw data that comes out of that temperature sensor, I'll show you what it looks like. So there's a read temp raw. Now each sensor has a unique serial number, and this just happens to be the unique serial number. So if we say my sensor, I'll do that. And you get this back. And the things which are vitally important is, does that say yes? Because if it doesn't, it means it hasn't read it correctly, so you need to try again. And then the next important bit is this T equals 222437, which is the actual temperature in milli-degrees centigrade. So we some of the library functions do the business of decoding all that information out of the string, which I won't actually go into because it's a bit horrendous. We're going to use the same universe type of operation on this. And what the universe wants is an image. So it's designed for drawing images. So we need to make an image of the temperature value out of the sensor, which is what this thing does. It makes some text image out of the sample that comes back from the sensor, and it draws it in 48-point text in indigo. So if I say draw so just draw sample. And then I need to get the sample, so we need to call another function, which is going to be this thing, read temp. Copy paste that. We need to read that temperature data from my sensor. Not too many brackets there. You get used to knowing where the brackets need to go, because for example, in this editor now, it's highlighted where it thinks that those brackets sort of start and finish. And there's one missing there. I need to do that to make it work. And if I do that, it draws the temperature as an image. Now it's actually putting the time up, but of course the poor Pi is confused about what time it is because it hasn't got an internet connection. So that's the image we're going to use in our world. And so equivalently down here, we've got this Big Bang thing which says we want to read the temperature sample, and then on every tick it updates the sample, and then it draws the sample. So try this out on justice. We've got a thermometer on the screen, and if I hold the Latin principle, it should go up. So that's really just an example of the, using the Edukit hardware with a different language. And programming language, I mean, clearly Python is the definitive, Python and Scratch are definitive languages for the Pi, and that's for very good reasons. But there's a whole universe of languages out there. And when someone says, oh, programming language X is better than programming language Y, what it actually means is, I like programming language X better than programming language Y. So there's no rights or wrongs in this. I might quite like languages like Racket, and it is a huge ecosystem, Racket, and it's got very, very good educational background. It's taught in the States. There's a program called Bootstrap in the States, which uses Racket as its teaching language. I've got a lot of sort of collateral material for this if you want to follow it up. The documentation of Racket is really, really one of its strong points. So if we put our cursor on something like say Big Bang there, press F1.
Program's still running.
That's very good. Yes, we get the manual entry for that. So yeah, I think the documentation of Racket is second to none really. And there's all sorts of subsystems. For example, there's a complete publishing system built in Racket called Pollen. And that had been developed by a guy who was a typographer by trade rather than a programmer. And he's used Racket to build a really excellent publishing system. He's very entertaining as well. So his talks, there's one on the internet called Like a Blind Squirrel in a Ferrari, which is a description of making his publishing system. And it's an entertaining experience. So finally, just more information. I've got a little bit more information there. It links to some extra stuff about Racket. Thank you.
Okay, thank you very much. Is there any questions?